All right, let's dive in. Today, we're going to talk about the ultimate story. You could call it the story of stuff. It's the story of the fundamental building blocks that make up, well, you, me, the screen you're looking at, and literally the entire universe. So, to really get a handle on, well, everything, we've got to start with one simple question.
It seems simple, right? But the answer, that's where we get right into the heart of chemistry. See, to figure out what we're made of, we first have to ask, what is anything made of? And that leads us to the biggest, most fundamental idea of them all.
And that big idea? It's matter. Yup, we're starting right here, in the world of matter. This is pretty much ground zero for understanding, well, you guessed it, everything.
So, what is matter really? The definition is actually super simple. It's just anything that has mass and takes up space. That's it. If you can weigh it and it takes up some room, it's matter. So yeah, that phone in your hand, the air you're breathing right now, even that coffee you're drinking, it's all just stuff, the stuff of the universe.
Now, this stuff comes in a few different flavors, or what we call states, and you already know most of these, for sure. You've got solids, like a block of ice, right? It holds its own shape. Then there's a liquid, like water, which will just take the shape of whatever you pour it into. A gas, like air, goes even further and just expands to fill up the whole room. And then there's the really cool one, the fourth state, plasma. Think super hot, super energized stuff, like what you'd find in the sun or a lightning bolt.
Okay, so everything is matter. Got it. But, obviously not all matter is the same, right? A rock is different from the air. So how do scientists start to organize all this stuff? Well, that brings us to a really important split, the difference between substances and mixtures.
So at the very top level, you can basically sort all matter into two big groups. And the key difference? It all comes down to chemical bonds. In one corner, you have pure substances. This is where everything is chemically locked together, totally uniform. And in the other corner, you have mixtures, where stuff is just kind of tossed together physically. No new chemical connections are made at all.
Just think about it. If you have a fruit salad, a piece of strawberry is still a strawberry right next to a blueberry that's still a blueberry. They haven't merged into a strumberry. Same with salt water. It's just salt particles and water molecules hanging out together. Nothing has fundamentally changed to create something brand new.
All right, so let's set those forced marriages aside for a minute and focus on that other group, the pure substances, because this is where we find the real, honest-to-goodness building blocks of chemistry, elements and compounds. Let's start with the element. A great way to think about elements is like they're the primary colors of the entire universe. They're pure substances made of only one type of atom. And here's the kicker. You can't break them down into anything simpler by any chemical method. They are as fundamental as it gets.
And you know these, of course. We're talking about stuff like the oxygen we breathe, the carbon that's in basically all living things, or the gold in a ring. All of them are elements, pure, simple, and absolutely foundational. Okay, so what happens when you take those primary colors, the elements, and you chemically bond them together? Well, that's when you get a compound. Now, unlike a mixture, this is a true chemical marriage. The elements join together in a very specific recipe to create something completely new, with its own totally unique personality. Water is the classic example, and it's perfect. Think about it. You take two atoms of hydrogen, which is a gas, and one atom of oxygen, another gas. You snap them together chemically, and boom, you get H2O, liquid water. It's nothing at all like the gases you started with. That's the magic of a compound. You create something brand new.
So I've been throwing this word around a lot, atom. To really get what elements and compounds are all about, we need to zoom way, way in. As far as we can possibly go, and meet the tiny little particle that's running the whole show.
So what exactly is an atom? Simply put, it's the smallest single unit of an element that you can have that still counts as that element. One single atom of gold is still gold. But if you try to break that atom apart, well, it's not gold anymore. It's the absolute smallest piece that keeps its identity. And every single atom is built from three even smaller parts. Right in the middle, in this dense little core called the nucleus, you've got your positive protons and your neutral neutrons. Then, zipping around the outside are the negative electrons. But here's the most important part. The number of protons is like the atom's ID card. It tells you exactly what element it is. If it has 6 protons, it's carbon, every time. If it has 8, it's oxygen. It's that simple, which is kind of amazing.
Okay, quick recap. We've got our building blocks, right? We have elements, we have compounds, and we know they're all made of atoms. So, what's next? How do they all interact with each other?
Or to put it another way, how does chemistry, happen?
Well, it all goes down in something called a chemical reaction. This is the main event, the action sequence of chemistry. It's basically a process where you take your starting stuff, we call those reactants, and their atoms break their old bonds and then reshuffle to form completely new bonds, creating brand new stuff, the products.
And this leads us to what is maybe the single most important rule in all of chemistry. Ready? In a chemical reaction, atoms are not created and they're not destroyed. They are just rearranged. That's it. You have to end up with the same exact atoms you started with, just put together differently. The Lego analogy is perfect. You take apart a Lego car and you use those very same pieces to build a Lego house. Nothing new was added, nothing was lost.
And that kind of leaves us with a pretty mind-blowing thought to wrap things up. If everything around us, everything we can see and touch, is just atoms rearranging themselves into different combinations, it really makes you wonder, doesn't it? What amazing new materials, or life-saving medicines, or world-changing technologies are still out there, just waiting for someone to figure out the right way to rearrange the atoms? The possibilities, they're literally endless.